Let us consider one more problem on Coulomb's law, where this problem has been asked into your annual exams for 5 marks. So quite an important problem. Point charges of plus 10 microcoulomb, comma, plus 20 microcoulomb and plus 4 microcoulomb are placed at the corners A, B and C of a right angle triangle. If AB is equal to 1 meter, CB is equal to 0.6 meters and AC is equal to 0.8 meters, calculate the resultant force on the charge at C. Now into the question paper, if you have ever seen one of the question papers, if you see this, it is a similar problem only with some values changed. So to begin with the solution of this problem, I'll first consider a right angle triangle. So let us draw a right angle triangle which is ABC, where they have said the distance between A and B is 1 meter. Distance between C and B is 6 meters and distance between A and C is 0.8 meters. So we just name these points where we have all the vertices named. The charge at one point, that is at corner A, is 10 microcoulomb. The charge at corner B is 20 microcoulomb and charge at corner C is 4 microcoulomb. I'm writing this values of microcoulomb getting converted into 10 to the power of minus 6 coulomb. Further, let us find force on C due to A first. That is, we're going to consider them as two separate entities right now. So we'll first find what is Coulomb's law between the charges at point A and point C, where the values of charge as well as the distances between them is known. So using Coulomb's law, I have force between C and A is 1 upon 4 pi epsilon naught charge at point C into charge at point A upon square of the distance between the two charges. I get FCA is equal to 9 10 to the power of 9 into 4 10 to the power of minus 6 into 10 10 to the power of minus 6 divided by the square of the distance, which has to be 0.8 the whole square. On simplifying, this gives you a value which is 360 10 to the power of minus 3 divided by 0.64. Hence you get the force between C and A equal to 562.5 10 to the power of minus 3 Newton. Now this is the force that we have found out between A and C. Now let us find what should be, okay, this should give you the direction of force which is FCA, which is pointing from A towards C. And you can say this force acts along AC. Now let us find what should be the force on C due to B. So the force between C and B, again with the help of Coulomb's law, I can write 1 upon 4 pi epsilon naught QC into QB upon square of the distance between the 2 points, where you get FCB is equal to 9 10 to the power of 9 into 4 10 to the power of minus 6 into 20 10 to the power of minus 6 upon square of the distance between the two charges, which happens to be 0.6 the whole square. On simplifying, I get an answer of 720 10 to the power of minus 3 divided by 0.36. Simplified further to get an answer of FCB is equal to 2000 10 to the power of minus 3 Newton. Hence we find out the value for C as well as the direction which is along BC. Moving further, I have got two forces which are acting from point C, but both of them perpendicular to each other. Hence I'm now going to use vector law of addition, or you can say I'm going to use parallelogram law of vector addition, where to find out parallelogram law of vector addition, I have to use my expression which says the resultant of two coinitial vectors is given by root of p squared plus q squared plus 2pq cos theta. Please remember, theta is the angle between the two vectors. The resultant f, which happens to be a diagonal, is given as root of fca squared plus fcb squared plus 2 FCA into FCB cos, where values of FCA as well as FCB are known. We will substitute them to get an answer where we know theta is equal to 90 degrees. So on substituting, we get 562.5 10 to the power of minus 3 the whole squared, which is the value for FCA, plus 2000 10 to the power of minus 3 the whole squared, which is the value for FCB, plus 2 into 562.5 10 to the power of minus 3 into 2000 10 to the power of minus 3 into cos of 90. Simplify this, you will get 5.625 10 to the power of minus 1 the whole square, plus 20 10 to the power of minus 1 the whole square, where we have adjusted the powers with respect to the values, plus 2 into 5.625 10 to the power of minus 1 into 20 10 to the power of minus 1 cos 90. It is known cos of 90 is equal to 0. So simplifying further, I get an answer which is equal to f is equal to root of 31.64 10 to the power of minus 2 plus 400 10 to the power of minus 2, and cos of 90 is 0. Simplify this, you get an answer which is equal to 431.64 10 to the power of minus 2. Take the root of this value, which gives you f is equal to 20.77 10 to the power of minus 1 Newton. Now this happens to be the magnitude of the resultant force. So I can say f is equal to 2.077 Newton. I will now have to find the direction of this resultant force. So to find the direction of resultant force, let us take the angle between one of the component, that is FCB, as well as the resultant force to be equal to alpha, where tan of alpha is given as q sin theta upon p plus q cos theta, where FCB acts as vector p and FCA acts as vector q. Substitute your values, you get tan of alpha is equal to FCA sin theta divided by FCB plus FCA cos theta. Remember, theta is 90 degrees, so on simplifying I get 5.625 10 to the power of minus 3 into sine of 90 divided by FCB, which is 2000 10 to the power of minus 3 plus 562.5 10 to the power of minus 3 into cos of 90 degrees. It is known sine of 90 is equal to 1 and cos of 90 is equal to 0. So please substitute those values into the given relation to get your answer equal to tan of alpha, which sums up as 562.5 10 to the power of minus 3 divided by 2000 10 to the power of minus 3, which gives you 0.2812. Therefore, tan of alpha is equal to 0.2812, or alpha is equal to tan inverse of 0.2812. Finding out using logarithm books, we'll get alpha is equal to 15 degrees 42 minutes, which happens to be the direction of the resultant force, so, which is making an angle with FCB.